continue from the previous slide. Okay, to complete all the topics number 4. Okay, so let me share the slide first. Okay, so we start with the slide of designing structure for isothermal reactor. Okay, so algorithm for isothermal reactor design include the first one is a more balanced and design equation. Okay, whereby it has the algebraic equation, function, and then integration and differential equation, and then the red law, and then stoichiometry, followed by combination from the item 1, 2, and 3, and then you have to evaluate it, okay, to get the V or to get the T. Okay, so how we evaluate, right, by using a numerical method. Okay, so this numerical method or equation, you can find it in the appendix A4 available in the Fogler textbook. Okay, so this is numerical evaluation of integrals. There are 4 different types of the numerical evaluation. Okay, the first one is for trapezoidal rule, which is 2 points. Okay, so this is applicable to 2 points. Okay, let's say you have 0 and 0.2 for the conversion. Okay, so x here actually refer to conversion, and fx is in term of the the equation to get the volume. Okay, for example, in PFR we have V is equals to FA naught, alright, integrations of x to 0, alright, with the changes of x over with the negative RA. Okay, so this one would be the fx function. Okay, so let's say we have 0 to 0.2, x1 is 0 and x0 is 0 and x1 is 0.2. So in order for you to use this equation, first you have to calculate what is h. Alright, so the h is defined as the difference between x1 minus x0. Okay, so 0.2 minus with 0, you will have 0.2. Okay, meaning that the h, this one, you have to replace with the 0.2. Okay, so for fx0 and fx1, okay, you need to get the value for this one for x equal to 0. Another one is x equal to 0.2. Okay, so here you need to use the function. Okay, for example, for 1 negative RE here, alright, the value is 1. Another one, this is for x0. Okay, another one we have x1. Okay, let's say the negative 1 over RE, the value is 2. Okay, so you just put in the value. Okay, for example, for fx0, okay, it is 1. Okay, and then fx1 is 2. Okay, so 0.2 divided by 2 times with 1 plus 2, you will get the answer. And don't forget, after you add to this value, you have to times with the fn0. Okay, because v is equals to fn0, alright, times with the integration of x to 0 dx over negative RA. Okay, so don't forget to multiply with fn0. Okay, or otherwise you also can put it directly, the value of fn0 here, alright, over with RA, okay, fs for fx0, and this one fn0 over RA at x2 for the fx1. Okay, same, right? You will get the same answer. Okay, another one, we have a Simpsons 1/3 rule. This is applicable for 3 points. Okay, so let's say you have 0 and then you have a 0.2, okay, or or you can do it like you have 0 and then 0.4 and then 0.8. All right, so here x2 would be 0.8 and x0 is 0. So you just put it x2 as 8 minus with 0 over 2, you will have 0.4. Okay, so your x0 would be 0 and your x1, see x1 is equal to x0 plus h, means that this is 0 plus with the 0.4. Alright, so your x1 should be 0.4, the conversion. And for x2, it should be now 0.4 plus with again 0.4. Alright, which is x2 is equals to x1 plus h. This one should be 0.8. Okay, so the equation, function equation should be related with this one is for s equal to 0. This one is x1 is equal to 0.4 and this one x2 equal to 0.8. Okay, so make sure the value is referring to the negative 1 over RA here. Okay, or FA0 over negative RA for x at x equal to 0. This one negative FA over RA at x equals to 0.1, 0.4, and then plus with the what do you call it, negative FA0 over RA at x2 equals to 0.8. Okay, so you just this one, let's say this is 1, so 1 plus 4, let's say this value is 3, so 4 times 3 plus with the this one is 4. Okay, so you will have the V volume, okay, as the final answer. Alright, so let's say for the Simpson 3/8 rules, 4 points, okay, for PFR here. Okay, so let's say we have a x is around 0.9, okay, and 0, okay, dx over negative RA. Okay, so 0.9, okay, would be the fourth point, which is this one. So 0.9 here minus with the 0 divided by 3, you will get 0.3. So means between 0, x0 to x1 to x2 to x3, the gap would be 0.3. Okay, so for example, for x0, you should have starting from 0 and then x1 plus with the 0.3, we will have 0.3 here. And then this one is 0.6. Okay, and then we have this one is 0.9. Okay, so you have to get the value of the FA0 over negative RA for each of this function. Okay, this one is, this one darab tau 3 times fx1, this one 3 times fx2. Okay, so make sure you have at least 4 points. Okay, and this one is not applicable to like 0 to 0.8. Okay, because of what? Okay, let's say you have 0.8, your h would be, h is equal to 0.8 minus with 0 over 3. Okay, so you wouldn't get the what do you call it, one final answer. This was 0.8 divided by 3, you will get 0.2 something. Okay, so you cannot round it into like 0.3, 0.6 and 0.9. Okay, for example, let's say this is 0, so this one is 0.4. Okay, and then this one is 0.8. Okay, so you cannot have this one. Okay, next one is a Simpsons 5-point quadrature. This one you can apply to 5 points at least. Okay, for example, you can have x is 0% and then 20%, and then you can have around 30%, or sorry, 40%, and then 60%, and then 80%. So what is H here? Okay, let me move this first. So the XF here, or X4, the X4 here is 0.8. Okay, so the X0 here is 0. So 0.8 minus 0 over 4, you will have the value of 0.2. Means that starting from X0, it should be 0, and then X1 is equal to 0.2. Alright, for X2 it should be 0.4, and X3 is 0.6, and X4 is 0.8. Okay, so you have to use this one for 5 points. Okay, so just substitute the value of the fx0 and fx1 until fx4, alright, and do the summation and times with the h, alright, h is 0.2 here, so this is 0.2, alright, then you will be able to get what is f, okay, what is the v, alright, the volume. Okay, so in order for you to use this, the key point is, first you have to determine how many x do you have in the table, alright, and then the second one, which numerical equation that should you use, alright, based on the point. So for example, for the first one, trapezoidal rule, this one is for 2 points only, applicable for 2 points, okay, and this one you can use for 3 points. Okay, let's say you have a 5 points. Okay, so you can use this one plus with the Simpsons 1/3 rule. Okay, or else you also can use this one, tapi make sure this one address the H interval. Make sure it is standardized and consistent. Okay, you cannot get 0 and then 0.2, suddenly this is 0.5. Okay, so it would be wrong. Okay, your value, you won't get the accurate value for the volume. Okay, so this is trapezoidal rule, okay, the one that I explained just now in the previous slide. Okay, and this is the Simpsons 1/3 rule, okay, for the 3 point, which is h over 3 times fx0 plus 4 fx1 plus fx2. Okay, so h is x2 minus x0. Okay, so you can see the point here for trapezoidal is for 0 to x1, but for the Simpson 3-point rule, you have x0, x1, and x2. Okay, so the gap here, h, should be the same with x0 to x1 and x1 to x2. So let's say this is 0.2, so this one should be 0.2 also. Alright, so x1 will have the function of x0, and x2 will have the function of fx2. Okay, the value, this one. So this one is dependent for fa0 over negative ra. Okay, usually we will use this numerical to evaluate the volume for the PFR. Okay, because the PFR have the integration function. Okay, this is Simpson 3/8 rules for 4 points. Okay, look at the figures here, the graph. There are 4 kind of x. We have x0, x1, x2, and x3. Okay, and there are 3 h here. Okay, so this is 1, 2, 3, 4. Okay, so usually we will have like 0 to 0.9 lah. Okay, 0 minus 0.9 is about divided by 3, it should be 0.3. So you can get x0 is 0, x1 is 0.3, x2 is 0.6, and this one is 0.9. Okay, 0.9 would be the maximum one because we don't have conversion which is more than 1. Okay, it cannot be more than 1. Alright, so x1 is x0 plus h, x2 is x0 plus 2h, and this would be the ni lah, how you get the x1 and x2. Okay. Okay, so basically the gap here, the difference here must be the same. Okay, so this is the 5-point quadrature formula. Okay, this is applicable for 5 points. We have f0, F1, F2, F3, and F4. Okay, so this one you can apply to 0.8. Okay, because 0.8 divided by 4, you will get 0.2, means that this is for x equal to 0. This one is x equal to 0.2. Okay, x, what do you call it? X2 here is 0.4, and then x3 is 0.6, and x4 is 0.8. Okay, all right. So another one is the 4 and 1 plus points, where n over 3 is an integer. Okay, it must be in integer value. Okay, so xn to x naught. Okay, how do you get the h? Is depending how many function do you have. Alright, for example, how many column do you have for the x? Okay, so you can use this one. Okay, this is more than 5 points you can use. Alright. Okay, but make sure this n should be in as integer. Alright, so for n plus 1 point, where n is even numbers, so means that this should be like 20, 18, 16. Okay, so you can use this one. Alright, your raw data must have like the quantity of n is equal 20 to 18 or 16. Okay, must be in even number. Okay, so the hash would be Sn minus with x naught over with the n. Okay, so make sure you apply the correct one. Usually we will use this one lah. It's even number here. Okay, so let's do some exercise. Okay, so read the question. It's about the reaction A to B is carried out in a PFR. The entering molar flow rate of A is 0.4 mole per second. Okay, so actually this question I already discussed in the previous slide, remember, but we use that one to get the direct volume. But for this one, we will be using numerical to calculate the V. Okay. So using the data in the following table, calculate the reactor volume necessary to achieve 80%. Okay, shade area in figure 2-2 that would give the PFR volume necessary to achieve 80% conversion. So this question asks you to get the volume at x is equal to 0.8. Make qualitative sketches of conversion x and rate of reaction negative RE with respect to the reactor volume. Okay, so we have this kind of table. All right, remember the equation to get the V from the PFR is V is equal to Fn naught with the integration of x to 0 to x dx over negative RA. Means that you will have F is equals to Fa naught over with the negative RA times with the integration of 0 to x dx. Okay, so this would be the x-axis and this one would be the y-axis. Alright, so it is given only the value of x and also negative RA. So what you need to do, you need to do some extra calculations to get the 1 minus RA as well as Fa naught over negative RA. Okay, so the value of the Fa naught is given in this question, which is 0.4 mole per second. Alright, so looking at this table, there is 1, 2, 3, 4, 5, and 6. Okay, so this one is about 6 point. Okay, we have the final concentration is 0.8 and the initial is 0. Okay, means that okay, you can make it as you can what do you call it, get the H first, the value, which is 0.8 minus with the final conversion minus with the initial one over with the 4, you will get 0.2. Okay, so you will use 0.2 punya difference of the conversions. Means that you should have for the x naught is equal to 0, and then we have a x 1 is equals to x naught plus h, and then we have a x2 which is the x naught plus 2h, and then we have x3 x naught plus 3h, and then we have x4 is equal to x naught plus 4h. Okay, so get the value for each of the x here. So we have this one is 0.2, and then this is 0.4, and then 0.6, and this one is 0.8. Okay, so look at this table, which one is what do you call it, represent those x. So from here you just choose for this one, and then 0.2, 0.4, 0.6, and 0.8. All right, so put it into the equations. Okay, for this one, 5-point quadrature formula. Okay, so h over 3, you replace the h with 0.2, and then what is fx naught? Fx naught is here, which is 0.89, and then 4 times with the function of x1, which is at 0.2 here. Okay, then we have a x2. Okay, so let me do it this first. Let me write down first the conversions. Okay, and then for 0.4, the function is 2.05, so you times with the 2 here. Okay, and then plus with the 4 times with the function of the x3. x3 is 0.6, so just times with the 3.54 here, and then plus with the fx4, which is the 8. All right, so you will be able to get the total volume for this PFR, okay, which is 2.165 meter cube, which is 2165 liter.